Okay, question 1G. The real numbers a, b, and c are non-zero. Each of the following quadratic equations has a repeated real root. Okay, what does that mean? Discriminant is 0. Yeah, not necessarily the same value. Fine. So how many distinct real roots does the equation cx squared plus ax plus b equals to 0 have? Now, it's actually quite tempting to think that, well, if the first two combinations actually both have a repeated real root, then the third combination, which is this cx squared plus ax plus b, it might also have one real root. It's tempting to think so, but let's just do some maths to check. All right. So discriminant equals to 0, so no surprises. B squared minus 4ac equals to 0, and the other one, c squared minus 4ab equals to 0. Slightly weird. Uncommon combination of the letters. So we have these. Yeah. And what's the discriminant of this one? The discriminant of this one is a squared minus 4bc. Okay, so how can I check if this is 0 or greater than 0 or less than 0? Well, we need to use some substitutions then. Yeah. So now, because the answer says it depends on a, I'm tempted to sub in the expression such that everything is in terms of a. As in, I want b as the subject in terms of a, in terms of a, and then c as well. I'm tempted to do so because the answer says it depends on a. So maybe if I get an expression in terms of a, then maybe a has something to do with the final answer. Yeah? Okay, so let's do that. Now you might think, well, simultaneous equations, but I have 3 variables. That's fine because I just need b in terms of a. Yeah, I don't care about the exact value of b anyway. So let's do so. How could I do this? Well, lots of ways. Let's say b squared times c maybe equals to 4ac squared, and then now I can sub in. So 4a, 4ab. Yeah. Okay, and then what am I doing here? So bc equals to 16a squared. Yeah, hope the algebra is correct. Now I can jam it in. Easy jam. A squared, hopefully we could see, a squared minus 4 times bc, right? So 4 times 16a squared, which is negative 63a squared. Yeah, just by substitution. Okay, so does it depend on a after all? Not really, because a squared is always positive. And we know that a is non-zero. That's very important. A is non-zero, right? So therefore, there's no way that the discriminant is 0. And this is negative 63 times that, so this whole thing is less than 0. That means that this has no real roots. 0 real roots, because discriminant is always less than 0, no matter the value of a.